Hello, everyone, and welcome to part 2 of the string graphs webinar series. We're going to be continuing on from where we left off last time in the webinar, and we'll just take a look at a couple of things from the last webinar that we had. My name is Roger Wander, and I'm going to be leading you through this webinar today, where we'll take a look at how Nspire can help you with some of the processes that are involved in Activity 2 of string graphs. You'll recall that in Activity 1, we took a look at what happened when certain points on the X and Y coordinate axes were connected with lines. We called that stitching, and we produced a graph that's similar to this with curvature. And that was done with selected points, ones that you were told about in the activity. In Activity 2, we changed things a bit so that now we have the lines not being the axes, but the guidelines, if you want to call them that, are lines that have opposite gradients. And I've written that down here at the bottom of this slide as y equals negative mx and y equals positive mx. And will be so in a way, then, we're turning the stitching a little bit in an anti-clockwise direction. In Activity 2, what you concentrate on is the two lines that are used for guiding you are y equals negative x and y equals positive x, as shown in the screen. The 2 points that are used, that you are asked to start off with, the two given points are negative 10, 10 and 1, 1. As we did before in the first activity, I will today in the webinar take a look at lines that are similar to the ones that you have in Activity 1. They still have negative opposite gradients, but we're going to take a look at what happens when we connect y equals negative 1/2 x plus 1 and positive 1/2 x plus 1. So this example is going to help you with the extension of Activity 2. It'll also help you with the main part of Activity 2. Now, one thing that you need to understand is that because of the fractional gradient and wanting to keep the numbers as whole numbers, the points that we're going to be using today will only have even x coordinates. The first coordinates will be even numbers. That's just for convenience today, so we don't get mired down in fractional work. We're going to be connecting those key points, as you can see here, like we did before, and I'll be guiding you through how we do that with Nspire, and eventually building up a pattern that starts to look like that. It's stitching once again, and that's what we're going to be coming up with. But the main goal, probably the most challenging aspect of things, is looking for a parameter that can describe all the equations all at once, rather than separately and individually. We're going to be looking for patterns. Okay. And in the producing this, we're going to be coming up with a function that is using that format of having the gradient outside of brackets x minus the x coordinate of a given point plus y minus the given coordinate of the x of the point. Okay, well, let's take a look at and see what Nspire has to say about all of this and how we might do this. In the first part of this activity today for the webinar, we want to set up the screen and once again go to the settings. So I'm going to first of all set this up for relational graphing, and I'm going to adjust the window. Let's adjust the window first. The reasons for the adjusting will become clear once the equations are entered in. We remember that we go to the menu key, we look for window zoom. Up here at item number 1, we have the window settings. And in the window settings, we're going to make the X minimum be -11. We'll make the X maximum +11. Leave the X scale the way it is. We don't need much underneath the X-axis, so we'll make the Y minimum -1. This just allows us to see the X-axis rather than having it out of there altogether. We'll leave and the Y maximum, let's pump that up to 8. And we'll leave the Y scale as it was, automatic. And I'm just manipulating this by using my down arrow keys, or you can use if you're using your keypad. Remember, the keypad up here is with the is up here. You can slide the cursor along with that anytime you want to. Okay, we'll hit OK, and you see that we've got an adjusted window. Also, because this graph is going to be set up for relational graphing, we're going to change this from functional graphing, and we do that by pressing Control Menu. So Control Menu. And with Graph Entry Edit, we select item number 1, and we change down here to Relation, because we want to have these in Y = forms. What we're going to put in are our boundary or guiding lines, I guess, because remember, they're not the axes anymore. They're the lines Y = +1/2 X. And remember, for fractions, it's Control, divide sign, 1, press the down arrow key, 2, press the right arrow key. So there's 1/2 X + 1. When we press enter, we'll get that graph. To put in the second graph, all you need to do is to press the tab key up here, and that reactivates and sets up for the next relational graph, which will be Y = negative fraction 1/2 X + 1. And we press enter. Now, for those two graphs, we're going to want to de-emphasize them a little bit, so we're going to change their attributes. You might remember from last week how we do that. If you don't, take your cursor over to the first graph here, say the -1/2 X, put the cursor there, and then press Control Menu once again. When you press Control Menu, you go to Attributes, and you notice that the first one is talking about the line weight. We're going to leave that as it is, but press the down arrow key. You can see that lit up on the screen over there. And then go to the right, because we don't want it to be continuous. We want it to be dotted. And now press enter, and that's now a dotted graph. We're going to do the same thing with the blue graph. Take the cursor, and remember, moving the cursor, you can use this keypad here on the handheld. take the cursor over here so that you've got that highlighted. Press Control menu number 3 for attributes. And on the attributes, we now go to the line style, go to the right to change from continuous to dotted, and simply press Enter. And now we've got our guiding lines that we're going to be using. Okay, well, at this stage, we're going to go to a calculator page that I've already set up. This is just to give us a little bit more time today. To get to that next page, Control right gets us to the next page, which is 1.2, and you should know that this is a calculator page. And I think it's important for you to see that what's been put in here is a series of comments. How do we find those? We're not going to enter them in today, but in the future, it might be good for you to know that by pressing Menu and going to Actions over here, we'll insert a comment. You see that down here in comment number 6. Now, I'm not going to insert any more comments, but that's how I put those in. And that gives me a little bit of a hint on this page, so I don't have to remember everything. I could look at a piece of paper, I suppose, but I want you to be able to see where I'm getting them from. Okay, we're going to be entering in 3 lines, and this is the information about them. Line 1, which I'm going to call Y1, contains this point, -10.6, and that's on this graph. That's up about here someplace, -10.6. And the point 2.2, which is on the blue line, y equals +1/2x. Notice that for all of these examples, the x-coordinate is even. That's so that when we take half of it, it stays as an integer. It's purely for convenience sake. Okay, so what we're going to do first of all is to do a calculation of the gradient of line 1, y1. We know the gradient is a fraction, so I go to Control Divide so that I've got the fraction template, and I'm going to follow that format of taking the y-coordinate of the second point, 2, minus the y-coordinate of the first point, which is 6. And then down here, we had 2 minus 6, and down here, we're going to put the subtracting the x-coordinates, so that's going to be 2 minus a -10. That's the gradient of the first point. Now, when we do that, you might be able to do that calculation in your head, certainly, but we do come up with -1/3. Later on, we're going to be changing that to a denominator of 6. And we'll see the reasons for doing that in a minute. But anyway, that's the gradient for line y1. Now, to find the equation of y1 and to assign it, we type in y1 down here. We type in y1, and then we press Control Mathematics template. So that's the colon with the equal sign. And our equation is going to be y equals, don't worry about the 2 equal signs there. The first equal sign is part of the assign function. The actual line is y equals. We want the gradient. I'm going to go up, press the up arrow key and capture that and press Enter. And it's a cut and paste technique from Nspire that's really good. Open the bracket, x minus the first the x-coordinate of the point 2,2, close the brackets, and then plus the y-coordinate of that second point, 2,2. So there's the equation of y1. Now, when I press Enter, it's written in a way that's slightly better able to see. You can certainly see the y-intercept. If you imagine this as y equals mx plus c, you can see the gradient negative 1/3. You can see the y-intercept of 8/3 coming in there. Now we're going to do the same thing for y2 and y3. y2 contains negative 8,5 and the point 4,3. And if remember, in the activity, you're actually given the points. Here, because I've made up a new function, I'm telling you what those points are. It's possible for you to sub in negative 8 into y equals negative 1/2 x plus 1, and you would come up with positive 5 for a y coordinate. But I've just done this ahead of time. Okay, we're now going to calculate the gradient of line y2, connecting those points. So once again, we have control divide for our fraction template. And the numbers we're going to put up on top, we have 3 minus 5, which is the y coordinates of those 2 points subtracted. And down below, we will have 4 minus a negative 8. Press enter, and there's our gradient of negative 1/6. That has the denominator that we're going to be using a little bit later on, just because it's common to both. 1/3 can be, the previous gradient can be changed into negative 2/6 when we want to. So we've got our gradient. Now for our equation, once again, we're going to assign y2, assign that with control math template. Y equals the gradient, negative 1/6, outside of open brackets, x minus the x coordinate of that second point on the line, because it was the point 4,3. So there's the minus 4, close the brackets, plus 3. When we press enter, we get another simplified version of the equation. But it's going to be really important to have this format, because that's where we're going to be able to do our predicting of the parameter from. Similarly, for the last set of points, and I'll just scroll back up here to show you what y3 was all about. And you can see what good idea this reminder ahead of time of having the information about line y3. The points are negative 6,4 and positive 6,4. You may notice that their y coordinates are the same, so there will be something interesting about the gradient coming up, but we'll go through the same format. So negative 6,4 and positive 6,4. The gradient for that will be control divide for the fraction bar. And up on top, we'll have 4 minus 4, the subtraction of the y coordinates, divided by 6 minus a negative 6. And of course, when we enter that in, we get 0, which we were expecting because they were horizontally across from each other. That line will be saved as y3, or it will be assigned as y3. So we press y3 and then control math template y equals, pick up the gradient again with an up arrow key and then press enter. That just copies and pastes. Outside of brackets, x minus 6. Because the second point was 6,4, so x minus 6, close the brackets, plus 4, and press enter. Well, having done that, that means that we're all set to put those graphs on our graph page, which was 1.1. How do we get back there? Well, if you have your cursor, you can use that to scroll up here and press this Enter key when you do that. And remember, moving the cursor, this just acts like a mini mouse pad. Or you can go to you can use another way to get back to page 1.1 is to press Control left arrow, and I'm going to do that. Well, you'll remember that we put those in as relation 1 and relation 2. If I press tab, it's ready for my next relation. And we've already got them saved, so there's no need to type much in here. We just are going to put in y1, then y2, and then y3. You will remember from last week that even if you don't want to type in y1, you can grab them from the variables because it's been saved here in the variable key. I go over here, I select y1, press enter, and there's our first line connecting negative 10, 6, which is up here, to positive 2, 2, which is up here. Notice, by the way, for those of you who are trying to figure out how does that become 2, 2, the scale on the y-axis is been marked. Each of these tick marks along the y-axis is 0.5, so it takes 4 of them to go up to 2. But each of the ticks along the x-axis is 1. It's always important to read what your screen is saying, and these values can be adjusted, but at the present time we're going to leave it like it is. To get the other two lines, we're going to press tab once again, and we'll put in y2. This time I'm going to just type it in, y2. Press enter, there's our second line. And finally, the line we're expecting to be horizontal, which is y3. Press tab, put in y3, press enter, there it is as being horizontal. Now, that's some of the lines, and we could have continued on with selecting other points, like you did in activity 1. You had actually 10 points. For this particular one, to show us initially, I've got a selection of 5 points that we're going to put in. But we're going to put them in by using parameters. If we want to be able to see the curved aspect of the stitching of this one, like we did for last week's work, we need to see more lines, and we need a general formula. So I'm going to go back to my PowerPoint slides, and I'm going to show you something here. So far, we have used the equation format that we used for y1 was y equals, and you'll notice a newcomer here. On Nspire, we used negative 1/3. Here, I've used negative 2/6. The reason for that will become apparent once we see the others. So that was our first line. And here's our second line. Y equals negative 1/6 x minus 4 plus 3. That was y2. And y3, instead of just being 0, I've called it 0 over 6. The reason for this is that the big challenge in these activities is looking for the patterns that link the equation number, here it's 3, here it's 2, and here it's 1. The equation number with the values that you see here. And there's one value that's staying constant. It's the 6 that's down below. Now, I know I had to manipulate negative 1/3 to become negative 2/6, and I had to manipulate 0 to become 0 out of 6. But sometimes we need to do this in searching for a parameter in order to be able to see the pattern more clearly. At all other times, we are going to take a look at these three and try to figure out, well, what is it that links up the negative 2, the 2 in equation 1. In equation 2, how did we get the 1, the 4, the 3, or the negative 1, the 4, and the 3? In equation 3, how did we get the 0, the 6, the 4? In other words, we want to see how we can fill in these blank spaces so that we can turn it into what we call a function. We saw this last week. We saw this in activity 1, And we're going to be trying to develop a functional graph where t, the parameter, is a number that comes from a set of values. Well, I'm hoping that with just this little bit of time left, that you have already been able to see what's happening. Take a look at the number that's hanging out here, 2, 3, and 4. They come from equations 1, 2, and 3. It looks like this number is one more than the value down here, which remember is what we're going to be calling t. So let's just keep that in mind. That's going to be t plus 1. Let's take a look at these numbers here. 2, 4, 6. 2 is twice 1, 4 is double 2, 6 is doubling 3. Maybe this should be 2t. And finally, negative 2, how does that compare to 1? Negative 1, how does that compare to 2? 0, how does that compare to 3? I'm hoping that you can see that the number that's in the numerator of the gradient, as long as the denominator is 6, the number that's in the numerator is 3 less than the value of t. Negative 1 is 3 less than 2. Negative 2 is 3 less than 1. Okay, keeping that all in mind, let's go back now to our calculator page and assign some variables for t. So I'll go back to Nspire. The calculator page was 1.2. I'll get there by pressing Control right. The parameter t is going to be assigned. Remember, that's Control Math Template. And it's going to be assigned as a set of values. And the set of values has to be put in the curly brackets, which are, you can see above, on the keyboard, they are just above the closed brackets that we have just to the left of the 0 key. When I press Control those brackets, I get both the opening and the closing brackets, and it's inviting me to put some numbers in here separated by a comma. Remember, the comma key is down here. That's an important one. Well, I'm going to set this up initially for the numbers 1, 2, and 3, but also a couple of additional numbers, 4 and 5. I press Enter, and that means that Nspire will remember what the t values are for those 5 numbers. Okay, well, you might remember from the PowerPoint slides, so I'll just flick back to that for a second, that we're going to be using functional notation, not relational notation. Functional notation requires a different kind of way to get that onto the screen. Instead of assigning the value, we're going to define. Now, you can type the word define if you wish, but the menu in the calculator mode, under Actions, the very first one, because it's one that we use so often, is Define. So select that. Type F, open brackets, and we're going to put an X, then the comma, and then the letter T. Now notice at this stage, T is highlighted in bold because we've just assigned values to it. So Nspire is telling us that. And what is that going to be equal to? Close the brackets. And remember, F, that whole notation, F brackets X comma T, that's the same thing as Y. So we're going to put in an equal sign and then put in what the equation looks like. The remainder of the equation can come from what we saw here. Something over 6, brackets X minus something plus something else. And if you were remembering or writing down a couple of things, you notice that the fraction, which is, remember, Control Divide, up here is going to be 3 less than t. So t minus 3. Down below in the denominator, we have 6. And you notice I got there by using my down arrow keys. I'm going to use my right arrow key to take the cursor to the right of the fraction. Really important to do that. Otherwise, everything you type stays in the denominator. You have to tell the machine what to do. You're in charge, not the technology. So there's our gradient. We open the brackets, and we're going to type x minus. Now, it was x minus, remember again, from the format that we had. We saw the 2, 4, 6. That was the doubling of t. So I'm going to go back here and just write 2t. I'm going to close the brackets, and then remember finally from the form, 2, 3, and 4 were 1 more than 1, 2, and 3. 2, 3, and 4 were 1 more than the value of t. And so we're going to put plus t plus 1. So the function looks messy. It's all defined for us. And we're ready to graph it. Now I've chosen to put this graph on a completely new page, another graphs page, and that's the 1.3 that's up here. I'm already on page 1.2, so I go to Control right to get to 1.3. I set out the axes to change the settings so that we're -11 to +11 along the x-axis, but we're all ready to type in our function. We have f, open brackets, x comma t. Close the brackets, and when I press enter, we should see all 5 graphs for those t values, and they're there. So we get the first 3 that we had in the previous graph. I'll just flick back to that for a second. We have those 3, but these 3, those 3 have been complemented by others on the right, giving us a bit of symmetry. If we want to zoom out from that, we go to Menu. Item number 4 is Windows Zoom. Go to the right, and we will zoom out. So that's item number 4. When we press enter, we have a magnifying glass. Let's just put that near the center of all the action here and just tap. You can do the tapping on your mouse pad here, and you get a little bit better sense of the curvature. Just one last one, because this is an unusual function that I've used. If you want to see this a bit better, we can go back to page 1.2, and I can alter the t values now to give us a few more points. You notice 3 is in the middle. So if I put the same number of values going in, maybe an additional few to the left of 1 and then to the right of 5, that'll give me a chance to see the structure a little bit better. You won't have to worry about this with the graph that you're going to be doing in the activity, at least if you do -1/2x in the extension and +1/2x, because I've changed things a bit. But if you wanted to see further ones, say if I wanted to do -2, -1, and 0 on the left, and then add the same number of extra values, 6, 7, 8, and press enter. Now Nspire will remember those as the t values, and notice what happens when I go now to page 1.3. I've got many more lines. I've got a better idea of the shape. I could go to the menu. I can zoom out using that as my center, and a much better picture of the curvature that we have seen in Activity 1 and will see in Activity 2 appears. Okay, well, thanks everyone so much for attending today, for watching this video with us, and I hope that you've picked up some valuable information about what to do in Activity 2 of string graphs, and I will look forward to seeing you next time. Bye for now.